Pak Dekan, meskipun ini hari libur ya Pak Dekan, tapi kita tidak pernah
Okay, no
libur
problem.
memang. Okay, and then for Associate Professor Mageswary Karpudewan from Universiti Sains Malaysia, good morning, and thanks.
Yeah, good morning,
for your,
Professor.
Yes, and thanks for your coming again. And all
Thank you for inviting.
Okay.
Thank you. Sorry.
Yes. Ladies and gentlemen, in our department, we have the course of Problematics in Chemistry Learning. In today's lecture and the next 3 meetings, the topic of misconception in chemistry is given by Associate Professor Mageswary. She is an expert in science and chemistry education, especially in green chemistry and climate change. She also is editorial board member of some high impact journal. Excited. Hopefully, that we can continue our cooperation in a near future. We hope this lecture will be highly educative and prospective for all of us. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Dr. Norma.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Sriamtina, or I call her Butina, for the nice opening speech from the head of Master Program of Chemistry Education. And we will continue to the next speech. Pak Dekan sudah bersama kami walaupun public holiday, karena ini pemerintah menggeser, jadi bukan salah kita juga. Pak Dekan, monggo untuk memberikan sambutan, please give the speech and open officially this program. Monggo Pak Dekan, time is yours.
Okay, thank you very much, Ms. Norma. Honorable Professor Dr. Mageswary Karpudewan from Universiti Sains Malaysia. Honorable Dr. Sri Yamtina, the head of Master Program of Chemistry Education. Dear participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good morning.
Good morning, Professor.
Yeah. On behalf of the Faculty of Teacher Training and Education, Universitas 11 Maret, first of all, I would like to welcome you all to the virtual visiting lecture with the themes Misconception in Chemistry. This activity will have 4 times start in today. Thank you very much for joining this virtual visiting lecture. Secondly, I would like to express my sincere appreciation to the Department of Master Program of Chemistry Education for hosting and organizing this event. This virtual visiting lecture is one of our event to respond the condition of COVID-19 that affects to all of our life, including the education sector. Today we live in new normal era in condition and post-COVID-19 pandemic that require new behaviors, new challenges, new opportunity, and also new competence. Education institution must adapt to all the changes. Related to our institution, the Faculty of Teacher Training and Education, this condition is very challenging. During COVID-19 pandemic, most of our activities will be held using online platform. However, skill and competence requires hand-on process in the real condition of work. At this time, my faculty have some international events, namely overseas student exchange, overseas lecture exchange, joint conference, joint research, and joint publication with university from national university and overseas university. The faculty has a strong commitment to facilitate these activities. Therefore, I would like to encourage all study program in this faculty to initiate and carry out the activities. And I also wish there is a collaboration between UNS and Universiti Sains Malaysia. Allow me to take this opportunity to convey my deepest gratitude to speaker, Professor Dr. Mageswary Karpudewan from Universiti Sains Malaysia for your availability and willingness to share your knowledge, experience, and expertise. I would like to express my genuine appreciation to all participants who are taking part in this lecture. Without you all, the activity would not have been possible. I wish you enjoy this lecture and get more benefit from this lecture. To fulfill the committee's request by saying Bismillahirrahmanirrahim, I declare the virtual visiting lecture is officially open. This is all my speech. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Warahmatullahi wabarakatuh.
Yeah, thank you very much, our Dean, Dr. Mardiana, for your speech and also your opening to this visiting professor program with Dr. Mageswary Karpudewan. And thank you very much, Pak Dekan, Prof. Sulis, Butina, for this nice opening ceremony. Yeah, because this is public holiday, so everybody is busy in the malls and with their family, but the student is already ready with the all of the critical discussion, and also one thing that want to learn knowledge and your expertise, Dr. Mages. Thank you very much, Pak Dekan, Prof. Sulis, Butina, for this nice company to this opening ceremony. And then let me continue to the main agenda, is the lecture given by Dr. Mageswary Karpudewan. Okay. Prof. Sulis, Butina masih bisa menemani sampai beberapa saat. Pak Dekan, terima kasih juga sudah membersamai, Pak Dekan.
Okay. Thank you very much, Ms. Nurma.
Okay. Dr. Mages, very happy to see you again in this course. And before we continue, let me introduce yourself, and then I will share your curriculum vitae to the students. Is it okay?
Yeah, it's okay.
Yeah, okay.
Thank you. Go ahead.
Yes. All right. Ya, Butina tadi sudah banyak menyampaikan beberapa hal terkait Dr. Mages. Ini hanya melengkapi saja. So we know Dr. Mageswary Karpudewan as Associate Professor in Universiti Sains Malaysia. The field of specialization is science education, ya, in School of Educational Studies, Universiti Sains Malaysia, Penang. Ya, kalau Mages bilangnya Penang, kita Penang gitu ya. Penang gitu ya, Mages ya. Okay, and if we can see in academic and professional qualification of hers, is a specialization in chemistry, Bachelor of Science in Chemistry, Diploma in Education of Chemistry, and Master of Education and Doctor of Philosophy is a graduate from Universiti Sains Malaysia in discipline Science Education. And if there are 13 pages here in her curriculum vitae, is very, very outstanding curriculum vitae. I met her in the first time in Bremen as invited speakers in University of Bremen at that time in 2014. And then, yes, after reading all the publication and all of the award that she already obtained, it's very, very outstanding. We can see her name is in top tier international journals. This is, we know, right? Chemistry Education Research and Practice. The article of the journal, very often we can cite from that. And then, yes, still many things that I can show to you regarding the publication and also the project that is run by Dr. Mages Research Group. Okay, I think that's all for the brief curriculum vitae. I can make it very short from 13 pages of yours, Dr. Mages. And Dr. Mages, as we discussed before, I think 1 month ago, we have discussed that we will have 4 meetings class. And the theme is misconception in chemistry. We start with the misconception, and the next we will also learn about the instrument who diagnose the misconception, and also the theory of conceptual change. And the last, because you will be in the 4th meeting, so students in problematics of chemistry education, and additional assignment for pengelolaan bahan ajar. Also, we have 11 students here, Dr. Mages. Jadi nanti akan ada tugas untuk mahasiswanya ya, nanti di akhir akan ada presentasi seperti itu ya Dr. Mages. Jadi nanti ada penugasan di meeting ketiga, untuk meeting keempat nanti teman-teman akan istilahnya mempresentasikan hasil kerjanya. Jadi karena ada 4 meeting, tidak hanya mendengarkan saja tetapi juga berdiskusi dengan beliau, termasuk nanti ada tugas gitu dari Dr. Mages dan perkuliahan ini untuk teman-teman bisa berdiskusi, dan Dr. Mages bisa memberikan feedback termasuk nanti penilaian untuk topik di subtopik misconception in chemistry. Itu Dr. Mages, anything to add information?
It's okay. During the sharing, I will just add on whatever is required.
Okay, good.
Right.
Okay, you can start with if you want to share screen, Dr. Mages?
Right.
We will have this first meeting until 11:45. 12:45. Sorry.
Can you see my screen?
Yes.
Yeah. Right. Okay. Thank you, Dr. Nurma. Thank you. So before I start with my session today, I would like to express my sincere thank you and gratitude to the university, the Pak Dekan, Professor Dr. Mardiana. So it was a very wonderful information that he have actually put it in the welcoming speech just now. I'm very grateful for inviting me to have me here today. And also, I would like to say thank you to Head of Chemistry Department, Professor Sri Yamitima, if I pronounce well, Yamitima. So thank you again for giving me another opportunity to be with the chemistry education student. And also the course coordinator, Professor Sulistyo. Thank you very much to be here.
Yes.
Yeah, right. And also my fellow colleagues, if there are any other colleagues around. Thank you for attending the session. And the students, okay, the students to be here to get to hear the whatever I'm going to talk about on the misconception. And thank you to Dr. Nurmal to giving me the opportunity to share my knowledge on misconception in chemistry and in science in general to the students in the chemistry education students. And I didn't know today is a public holiday over there in Indonesia because our public holiday was yesterday.
It should be yesterday. It should be yesterday.
Yeah.
Because the government policy to, I think, to reduce the mobility of people, I guess.
Oh, okay,
Yeah,
okay,
yeah.
okay.
In the pandemic.
Okay, okay.
Yes.
I understand. So yesterday was a public holiday here, so we had a short break. So we enjoyed the break. Anyway, all of you have sacrificed your public holiday, I suppose, but I try my best to do it in maybe 1 hour, 45 minutes or so. And I try my best to deliver in a way it is informative and beneficial to all the students and also other academic staff from the university. And also, I listened to your introductory lecture or the short video on the to the university. I didn't see the earlier part. I only managed to see the last part. That was wonderful. That's very good. The university looks very green, you know. So
Yeah.
yeah, you know, in USM we are actually talking about greening, and sustainability is one of the, I mean, is the vision and mission of the university. But I look at your university is really green, you know. So perhaps maybe one day I could pay a visit to
Yes.
the university.
You should visit us
Yeah.
when the pandemic is over.
Right.
Prof. Sulis, maybe we have another information, Prof. Sulis. We have in the 6 green campus matrix.
Okay.
Yes.
Yeah.
We are number 7 in
Oh, number 7
Indonesia.
now. Okay.
Yeah. So that's very good.
Metric, green
Yeah.
Green metric. Yes.
Green metric. So I think we are leading in the green metric. I suppose 1 or 2. I'm not sure that, but one of the
Alright.
top in the list for the green metric. So hopefully our collaboration will continue with some publication and so on, and see what else we can do together, you know, to show some outcome. You know, the lectures, the 4 lectures doesn't just simply stop there, but as an outcome of these 4 lectures, end of the day, we have some tangible product. We can see something, not only in terms of knowledge, but in terms of other things, probably papers or some other things, a grant or something like that. Okay.
Yep.
So thank you for visiting me, for what you call that, inviting me. Right. So in the first lecture, what I'm going to do is I'm going to talk about misconception. I'm going to talk about the sources of misconception and the different type of misconception that occurs across the chemistry education and also science education. Okay, so I hope with this information, students will be able to take this information and they can actually match with their own context in their own teaching or their own experience, what kind of misconception they always encounter, and as a teacher, what they should do. They cannot simply leave the misconception as it is, but they must take the responsibility to address the misconception. So I will go in detail about several misconceptions in chemistry and science. I think that they should know about what are the misconceptions, and these are the things that they should look forward before they start their lesson. Okay, so that will be mainly the first week's lecture, the first session. The second section, I will talk about the diagnostic instrument, as Dr. Nurma has mentioned, the instrument or diagnostic test. So I will introduce various diagnostic tests, the tests that we have developed, and also the test which is available by other researchers which they have published, and I will introduce that to you all. And also, if time permits, I will try to go into the theory. Mostly that we will use is conceptual change theory by Posner. So I will talk about how you can actually bring the theory or connect the theory with your lesson. You have to design the lesson in such a way that the 4 elements of Posner's conceptual change steps are embedded within your teaching, so that misconception can be reduced or eradicated totally. Then the next one I will be talking about, I will show you some examples, some teaching strategies which uses this theory, which have developed based on conceptual change theory. So I will show you some of my own examples, and also I will show some examples which is already available in the literature by prominent researchers like Tregas, Dweet, and all these people. So they have already proposed some teaching approach which is really good, which we can actually use in our classroom. Okay, and the last lecture will be some of the presentations lah. If the students can identify, they already know what is the misconception, they're going to they're going to detect among your students, then you can actually look into that misconception, and you can actually think about how you're going to design your teaching. So how you're going to design the teaching based on the 4 steps of conceptual change model by Posner. Okay, so maybe the last lecture we reserve for that. Okay, right. Now, So let me start with the first lecture, which is on misconception and so on. Right. Now, before I can go deeper on misconceptions, as a student, you should know the difference between concepts and misconceptions. Okay. Concepts and misconception, or conceptions and misconceptions. So what is concept? Concept is an idea. Okay. An idea or a mental structure of a phenomena. So you conceptualize a phenomena when you say rate of reaction. So how you conceptualize the phenomena of rate of reaction is you're looking into how starting material, you have a starting material combination of two or more starting materials, you will manage to come up with a product. So let's say your starting materials is A plus B, your product will be C. Okay, A plus B, the product out of combination of A and B will result in C. So that means you have conceptualized that A will react with B, the result is C. So that is the conception. Okay, so that is your conception about rate of reaction. So similarly, you can conceptualize about an event. So for example, we are talking about global warming. So what is global warming? So the moment people say global warming, the idea that comes to you is climate change or increase in the temperature of the earth. So these are the conception. Okay. So now the conception that you have can be correct or can be incorrect. So when the conceptions are incorrect, this is called misconception. Later I will go deeper. You will realize that you need to understand misconception and not knowing. Okay, not knowing means tidak tahu langsung. Misconception is knowing. Kamu tahu benda tu, but you conceive it incorrectly. Okay, you conceive it incorrectly. You conceive it wrongly. Okay, so for example, climate change. When we talk about climate change, we assume that climate change is global warming. Yeah, it's true, but not necessarily global warming alone is talking about climate change. Global warming alone is not necessarily reflects on climate change. Climate change is more than global warming. So that is a misconception. Okay, so you need to be very clear between conception, misconception, and wrong conception. Wrong or not knowing. Okay, not knowing. Not knowing means you don't know anything. So if somebody explain to you, if somebody teach you, then you will get to know. Misconception, you perceive or you understand the object, the phenomena, the ideas incorrectly. Okay, right. So why this misconception is so important? Why do we need to talk about misconception? Okay, why so much of research has been done on misconception? Now, if you ask me at this point of time, if you just write a paper trying to detect a misconception, trying to identify a misconception among your students, probably you won't be able to get your article published, because studies on misconception is already so much. So many studies people have done on misconception. The area is so concentrated, it's so filled. How your study going to be different from other people's study? So just talking about misconception alone is not enough, but misconception is a very, very important field of research. As a chemistry educator, everyone should know about what is misconception, the history history behind misconception, how to identify misconception, how to eradicate misconception. Okay, this point you have to know as a chemistry educator, even though the field is already concentrated. Okay, right. So in the first lecture, I talked about conception is how you build the idea. Misconception is when the idea that you have built is not in line with the conception, or not the ideas that supposed to be the scientifically accepted ideas. Misconception is the idea that you have constructed is not in line with the scientifically accepted ideas. I'll talk about it very detailed later in the next few slides. Now, just look into the history behind how misconception came about. So the first time when the researchers got to know that misconception is in 1970s, or in late early 60s and late 60s and early 70s. So during that time, they got to know that when the student comes to the classroom, we as a teacher, we assume that the teacher, when the student attend the classroom, they don't have any idea about what we're going to teach. Like, for example, let's say we are talking about boiling point. Okay, we are talking about boiling point. So we as a teacher, I mean, this is a common scenario in all the countries. We as a teacher, we assume that the students do not have any idea about what is boiling. We assume that we think that is the way how it works. But then in the reality, in actual fact, students already know what is boiling. Where they got to know about boiling? Of course, at home they boil water. The mother boil water. They use many ways of boiling water. They use the stove to boil water. They use microwave to boil water. They use electric kettle to boil water. So they already have some idea about what is boiling. Okay, so we cannot assume that when the student come to the classroom and your lesson to that day, that particular day, you're going to talk about boiling. And you cannot assume that the students do not know anything about boiling, and you just start teaching the science facts behind the boiling. That's what happens in the classroom, in our classroom usually. But in reality, that is not the situation. Students already have some conception about boiling. So the existing conception was identified in 1963 and 1971. Piaget said that when the students come to the classroom, they already have some kind of knowledge regarding the concept that you're going to teach in the classroom. So as a teacher, you cannot ignore that prior conception. So that's what we call it, prior knowledge, prior conception, and prior understanding of, that's the common phrase used to describe the prior knowledge that the students bring into the classroom. So Piaget said that students do not come to the classroom with blank sheet, blank slates. That means dia tak ada apa-apa dalam dia punya pemikiran. We cannot say that in that way. So Piaget said that students always come to the classroom with some kind of idea in their mind. So as a teacher, before you start the lesson, you cannot simply start, okay, today's lesson is on deboiling. So I'm going to teach you about what happens when water boils. How the change of phase from the liquid to gas. You cannot simply start in that manner. What you need to do is, as a teacher, the first thing that you need to do is to identify the conception, the prior knowledge that the students carry with them to the classroom. So as a teacher, that would be the first step. Okay. Now, this prior knowledge can be a correct understanding. Okay. Students conceptualize the boiling process correctly, then you don't have a problem. But the prior knowledge not necessarily can be a correct conception. The prior knowledge can be an incorrect conception. So problem occurs when the students carry the prior knowledge which are not incorrect. And this prior knowledge is something which is very strong. You know, something which is very strongly held by these students. Because why? This is not a 1 day or 2 days knowledge. The knowledge not gained in a day or two, but this is a knowledge that they have gained throughout their experience at home. That means how many days they have seen the parents or the mother boiling water. You know, from the time they know what is water boiling, they already know. Okay, they have been observing what is happening when the water boils. So something which is very concrete in their mind. So it's not easy to eradicate that kind of misconception. Okay, so what happens is this kind of knowledge will interrupt the accurate construction of knowledge. If let's say the teacher ignore, okay, the teacher do not actually bother to identify the misconception, or the teacher assume that the students are coming to the classroom with empty mind, teacher ignore this kind of knowledge, then this will result in impacting the students learning the real or the true knowledge. Okay, so this is what Piaget have said and have identified in 1960s and 1971. Okay, so from that time onwards, many researchers have started to work on identifying the prior knowledge. Another popular advocate of misconception is Rosalind Derive. So if you have a chance to read about the book by Rosalind Derive, Pupils, Pupil. So the title of the the book is Pupil. So just go and read about that book and then get idea about what Rosalind Derive says about misconception in science education. And that book was written, if I'm not mistaken, in 1983. Okay, Driver. Okay, right. So when the conception is not in line with the idea proposed by scientific community, so the conception when it is not parallel, tidak sama with the ideas or the knowledge proposed by the scientific community, we call it as misconception. You know, beside misconception, some studies say they have used the word alternative conception, preconception. You see here, misconception, alternative conception. So they are very thin line of difference between the phrases. So misconception, it is already saying that the conception is already wrong. The word miss, it's already saying, indicating it is a wrong conception. Okay, but alternative conception is saying that the students are having another conception. Alternative is another conception which is not in line with the conception of scientific community. I hope you can follow what I'm saying. Misconception, the word miss itself, perkataan miss itself, it's already telling it's wrong. Okay, misconception, misunderstanding, wrong understanding. Okay, but here the alternative conception, it not necessarily refers to the wrong conception. They have another understanding, another idea about the concept. And these concepts, the alternative, another idea which is not in line with the scientific community's scientific community's view, then it is become a wrong understanding or misconception. Again, preconception. Preconception also, it's like prior knowledge. The prior knowledge can be correct or incorrect. You know, so it not necessarily must be a misconception. It's a prior conception, preconception. Okay, now the phrase that you want to use in your study, it makes a lot of difference, because if you are using a phrase misconception, that means you have to say in your study later, you need to say that the wrong understanding that the students have is actually referred to misconception. It is not that they do not know, or it is a wrong, it's a incorrect understanding. That means they misinterpreted the idea. So if you just use an open-ended question, for example, open-ended question. So you ask the students to answer, then you collect the answer, you mark the answers, you identify that the students are making mistake. They have few wrong answers. So these wrong answers, not necessarily a misconception. These wrong answers, probably they do not know. But if you're saying it is a misconception, you need to confirm that they are misconception. So what you need to do is you need to ask why you give this kind of answer. Can you explain why your answer is as such? So that the student will be explaining. Even though the answer is wrong, you can go further and then investigate further and ask the students why you have given this kind of answer. And then from there, you can actually identify whether this is really a wrong understanding or the students are having a misconception. Okay, so even though most of the time, when your reading or your experience is not so vast in this area, we will assume that misconception, alternative conception, preconception, alternative frameworks, all these are sama, is same. But in actual fact, they are different. Okay, they are very different. So that's why, especially when you want to publish in impact factor journals like Journal of Research in Science Teaching or International Journal of Science Education, Chemistry Education, Research and Practice, these kind of good journals, you cannot simply use misconception, or you simply want to use alternative conception. You have to be very careful. If you are saying it's misconception, in your instrument, it must show it is a misconception and it is not an alternative conception, or it is not a preconception. Okay, misconception is a conception which is not in line with scientifically accepted ideas. So scientists says that this is the real true idea for this concept, but when students have misconception, they have incorrect or the ideas which are not correct, in line with scientific community's view. Alternative conception, they have some other idea. This alternative conception not necessarily a misconception. If you are saying that the alternative conceptions are misconception, then you have to prove that these alternative conceptions are wrong. Same thing, preconception is a prior knowledge. The prior knowledge not necessarily can be wrong. It can be a correct understanding. So if you are saying the preconception is a misconception, then you have to prove that the preconception are misconception. Okay, so some studies have used alternative frameworks. Some have said naive belief. That means the belief before the students are exposed to the formal teaching. Okay, children's scientific intuitions. So intuition means you just see that you experience warm weather. For example, warm weather. The weather is really warm. So without questioning, without reasoning, simplistically you say that, oh, it's global warming. So that is the intuition. So that students simply just accept whatever they see as it is without reasoning. So for another good example is, we say boiling water boils. We boiling temperature of water is 100. So when the boiling water reaches 100 degrees Celsius, then we say water is boiling. But for children, as long as they feel the water is hot or warm, they say it's a boiling water. So it is a intuition. It's the moment they touch, they feel hot. Oh, this is a boiling water. But for chemists or for scientists, it is a boiling water when the temperature of the water is 100 degrees. Can you understand the intuition? Right. Now, so global warming is not necessarily increase in the temperature alone. The extreme weathers, heavy rain, you know, flooding, unexpected flooding. So all this we call it as another aspects of global warming. But for a general lay person, the person will say, oh, the temperature is very, very warm, very high. We can reach up to 36, 37 degrees Celsius in some days. Sometimes it rains 3 or 4 days, but for them, the rainy season is not global warming. But the increase in the temperature is considered as global warming. So these kind of intuitions, not necessarily children, even adults, we have this kind of intuition. Because why? We are not exposed to the real scientific facts. Okay. Conceptual frameworks also the same thing. It's not necessary something which is not correct. If you think the conceptual framework is a kind of misconception, then you have to prove it. Okay, so these are the several phrases that simplistically used by the authors or researchers to describe misconception. But there are a lot of, or there are differences between these concepts. Actually, when I start to write about misconception, I also had the same idea. I thought all of these are same. So in my writing, I started to use misconception, and in my writing, when I my first few articles, when I talk about misconception, then the reviewer asked me, how can you prove this is misconception? How do you know this is a misconception? It is not the wrong understanding, or maybe the students do not know, they have not learned before. They don't have the idea. So how can you call this as a misconception? So I assume that everything which the students do not know as a misconception. Then I wrote the article. So when I got back the review, I was asked to change. Don't use the phrase misconception. You change the misconception to alternative conception. Then I started to read. What is the difference between misconception and alternative conception? I thought both are same. Mereka sama. I have these thoughts. They are the same. So when I start reading, then I realized, oh, actually, misconception, alternative conception, preconception, naive belief, scientific intuitions, all these are different. So if you want to, all these alternative conception, preconception, all these are actually not necessary misconception. The students are having another idea, a different idea, a different knowledge, another perspective. So alternative conception, preconception, not necessarily a wrong idea. They can be a correct conception. So if you want to prove it is as a misconception, then you need to provide evidence. You need to provide arguments. Okay. So in next week's lecture, when I talk about diagnostic instrument, I will show you how to prove that these are misconception and not alternative conception. In this lecture, you just have to know. Don't simply use. There are a lot of difference between them. Okay. Right. Now, you see, for one of the general layperson's misconception, okay, layperson, we assume that in the market, okay, in the market, if you go to supermarket or buy any product, you will see chemical-free product. Okay, chemical-free product. The moment you see chemical-free product, you will think, oh, chemical-free, very safe, ready. I can consume. But as a chemist, I want to ask you, can you develop or produce or manufacture any products without chemical? Without using any starting materials? You are going to have some starting materials. That starting materials can be organic in the form, or it can be a hazardous chemical. But even organic products, they are also chemicals. Okay, so it's a misconception. Chemical-free products are safer. The first question that I want to ask you, can you derive any products which are chemical-free? You have a food dye at home. Okay, nak masak, nak guna pewarna. You're using, like commonly in Malaysia and Indonesia, we use pandan, daun pandan. Do you think there's no chemical structure in daun pandan? You know, you boil water, you put the pandan leaf into the boiling water, you boil the water in the kitchen, but you can get this flavor until to the front porch of your house. So that is a kind of diffusion. So the molecule diffuse through the air and reaches to the surrounding. So can we say that pandan is chemical free? So the word chemical free is literally used. These are misconceptions. This is not alternative conception. These are misconceptions. Okay? And we also cannot say that all the synthetic products, okay, synthetic products, for example, the products that are produced in the lab, are not safe for consumption. Some chemicals are good. You know, for example, you are using what do you call that? We have hair dye. You know, people use hair dye. They want to warnakan rambut, their various colors. You know, you can also have a organic. I want to use the word organic with the what do you call that? Carefully, the word organic. It can be, people simply use the word organic, literally reflecting it is chemical free. But not necessarily organic products are chemical free. They are also contains chemical. Perhaps the hazards of the chemical is lesser. You know, but they are chemicals. You know, maybe the chemicals are not harmful for people or the environment, but we cannot say there's no chemical. Okay, so this is a very basic, a very simple understanding. What is misconception? Okay, now I'll go another one. Organic products. You see, when you say you are using organic products, even fuel, you know, petroleum fuel, diesel, biodiesel, all these are organic, because where do you obtain the petroleum? It's from the sea, correct or not? So it is from fossil fuel. Decomposition of the dead materials at the seabed, you come up with the petroleum. So petroleum is organic. The nature of petroleum is organic. So you cannot say organic alone reflects a chemical free products. You know, so this is a misconception. It's a very common misconception. Go for organic material, organic food. Okay, organic food is safe. But then what is the meaning of organic food? We cannot say organic is chemical free, or we cannot say all the material that is produced in the lab are non-organic. For example, petroleum is organic. Same thing. Not all the synthetic products are not safe. For example, you have many food coloring which are produced synthetically in the lab. They are safe. You know, so these are these, you know, um, uh, what is the meaning of misconception? Not alternative conception. These are purely misconception. Okay, right. Water turns blue when copper sulfate is added. You know, so when we have copper sulfate, we add water, it turns blue. So if you ask 11 to 12 years old students, they will be saying that because the copper sulfate has a chemical inside, that it turns the water blue. So this is the answer given by 11 to 12 years old student. You know, partially they might be correct, because copper contains Cu positive 2. So the color, the blue color is because of the Cu positive 2. But then they have a misconception that it is just because of the chemical. Probably this is based on their interaction with the environment. A compound is a substance that contains two or more of the same kind of atom. Okay, a compound contains two or more of the same kind of atom. Not necessary, right? A compound can be a different kind of atom, right? So this is a kind of misconception which obtained from teaching, because I don't think so students will know about atom before they enter the class. Correct? So these are the misconceptions, maybe from the textbook of the teacher, or from the teacher. Hydrogen reacts with fluorine because fluorine wants to gain an electron and hydrogen want to lose one. Probably it's partially correct. You know, hydrogen reacts with fluorine, so hydrogen fluoride. Right? So what actually happens during the hydrogen, the formation of hydrogen fluoride? The students would not be able to explain accurately. So these are some examples of misconception. So if you see here, the earlier example that I've shown, organic, chemical-free substance, water is blue. The earlier examples, that are misconception, which is basically student get it from their everyday communication, or from reading, watching television or mass media, or interacting with their parents. You know, it is so common to use the word what do you call that, organic, you know, chemical free product, you know. And this kind of misconception which is shown here, the atoms, the reaction of two hydrogen and fluorine, you know, the reaction of two chemical, this is mostly from the textbooks and teacher, from the teacher itself. Okay, so there are many sources where students can develop misconception. You know, there are many ways students can develop misconception. So younger students, the most common way is interaction with the natural environment. Okay, so when they interact with the natural environment, they got the understanding, they build the understanding without even questioning, reasoning. They just say, oh, when you see the clouds, the student perceives that, oh, it's going to rain. But nowadays, not necessary when there is a cloud, it'll be raining, because the wind probably will take the cloud to some other place. You know, so it's not necessary it rains. So this is a kind of intuitive understanding. The moment you have cloud, oh, the next thing that you will be hoping for is rain. So this is a intuitive understanding. The other conception is from mass media. Mass media can be television, magazines, or any kind of reading, you know, newspaper or anything. So from the newspaper, you know that why is climate change is happening? Because of too much of CO2 in the air. But in the actual fact, greenhouse gases is not necessarily CO2 alone. There are so many other gases. Methane is also a greenhouse gases. But if you go and ask a lay person, they wouldn't know that. They only know CO2 is the cause for climate change. So this kind of misconception is from the mass media. Textbooks. Textbooks is also another major cause of misconception. So I would recommend the students who are participating in this lecture, try to read more articles published in Journal of Chemistry Education by ACS, American Chemical Society. So this journal, actually they have whole list of actually they investigate misconception in the textbooks, and they identify each and every misconception. So for example, I managed to get few, like in the topic of electrochemistry. So it's by Sanger and Greenbaum, 1999. So you see there's so many misconceptions. So for example, a very common one, you can look through all these, but I would like to highlight one or two from here. Electrons can flow through aqueous solution without assistance from the ions. So there is a misconception in the textbook, the wrong idea given in the textbook. Electrons can flow through aqueous solution without assistance from the ions. Now, so you have let's say you're having a cell, you have an anode, you have a cathode. You are expecting the electron to flow from the cathode to anode. How can the electron flow without an electrolyte? In the electrolyte, you have positive ions and negative ions. So what happens is, in the cathode, the positive ions will receive the electron from the cathode, and these electrons are transferred to the anode. So you need a road, a path. You need a carrier. So the carrier is the ions. But in the textbook, it is mentioned that electrons can flow through aqueous solution without assistance from the ions. So this is an incorrect information. Okay, right. So these are the conception. You can actually look into your textbooks also, Indonesian textbook. I can pretty sure there are definitely some misconception. Okay, in Malaysian textbook, yes, we can find many misconceptions. One reason why there are many misconceptions is because, I'm not sure about Indonesian context, but in Malaysian context, the books are written by teachers. So normally what the Ministry of Education will do is, they will consult experienced teachers. They are said as guru cemerlang, guru pakar or guru cemerlang. They will gather all these teachers, and there they will group them together, and these teachers will normally write the textbook. These teachers also refer to some other sources, their own experience, and also they also refer to various other sources. When they refer to other sources and their own experience of teaching chemistry, maybe for many years, they also have misconception, and these are misconceptions also translated in the textbook. So textbook is one of the main sources of misconception. Now, another one is, the anode is negatively charged and releases electron. The cathode is positively charged and attracts electron. Now, this kind of misconception happens because the students always misinterpret anode and anions, cathode and cations. Anode is positively charged electrode. Cathode is negatively charged electrode. So here they always tell anode is negatively charged and releases electron. So they think anion is negatively charged, cation is positively charged. So they always misinterpret anion and anode, cation and cathode. So there's always a misunderstanding here. Now, other examples is Cell potential are derived by adding individual reduction potentials or reduction reaction. Now, cell potential is keupayaan voltage. We measure voltage, right? How can you measure a voltage? See, in a cell, you need to have reduction and oxidization process, correct? Then only a cell complete. So that means there is a cell, there is a reaction which releases electron, there is a reaction which accepts the electron. So reduction, oxidization. When there is electron released, then the electron moves and the electron is accepted at one point. The movement of electron creates electricity. So the voltage is produced from the strength of the electron. You know how much of electron is released and moved, right? So if you only, and we call this as a half equation, we can write the equation reduction as a half equation, oxidization as a half equation. If you just focus it in one equation, reduction alone, can you think the reaction can happen? If you just focus on oxidization alone, can you think the reaction can happen? Voltage or the potential is measured, keupayaan, dalam bahasa Melayu kita sebut sebagai keupayaan. Voltage is measured when there is a release of electron and there is an acceptance of electron. So for releasing electron, you have a half equation, there is a reaction. For acceptance of electron, there is a half equation. So when both happens together, then only the reaction is complete. You can measure the voltage. How can you measure voltage only looking at one equation, reduction say, or only oxidization? So there is a misconception here. You know, cell potential are derived by adding individual reaction. It's not adding, but both happens together simultaneously, bersama-sama. It's not one add to another one. I hope you understand what I'm saying. Okay, right. So there are so many misconceptions on galvanic cell and also electrolytic cell. You know, electrolytic cell. So for example, you can say no reaction will occur if inert electrodes are used. So that means when you use carbon, you use normal reaction. Let's say we are using carbon. We are saying that the electrode itself won't react to the electrolyte. You know, there are possibilities for the electrode to react with the electrolyte. For example, in the case of copper, if you use copper, it can. Electrode itself can be discharged into the Cu positive 2 because the copper electrode can release electron and then produce Cu positive 2. So this is some kind of misconception related to electrolytic cells. You know, so let's say you want to do for example impurity. You want to your metal is not pure, you want to purify your metal. So you have two electrodes, one is impure electrodes, one is pure electrodes. So you can do the electrolysis and you can see that the impure electrode will dissolve, and then finally you will purify the impure electrode. So in this case, electrode itself will take part in the reaction. You cannot say electrode is inert and it won't take part in the reaction. This is incorrect. You know, so for example, in the purification of metal, this is what happens. Okay, right. Concentration of cells. So these are some reaction. These are some misconception that you can actually identify in the textbook. So when the concentration of the electrolyte, okay, concentration of the electrolyte actually influences the product at the anode and cathode. For example, let's say you are using, you are doing an electrolysis of copper sulfate aqueous. Okay, copper sulfate aqueous. So probably at the anode, you will produce hydrogen gas. It's not copper. You will copper sulfate aqueous, you have Cu positive 2, and at the same time you have H positive as in the electrolyte, right? So what happens is Cu positive, there are possibilities for Cu positive 2 to receive 2 electrons and form Cu, or hydrogen positive receive 2 electrons, become hydrogen gas. There are two possibilities that can happen. But in the case of when your electrolyte copper sulfate is really concentrated, let's say you are using 2 molars of copper sulfate, the product that you produce will be Cu positive 2. Let's say you are using Cu positive 2 aqueous, 0.001 molar, the product will be hydrogen. So you see the concentration of the electrolyte actually influences the product that can be formed in the at the anode and cathode. Okay, so the misconception is it is said that the concentration is not actually taking part in the reaction. So these are some misconceptions identified in the textbook. Okay, right. So you want more, you can actually refer to many articles. Okay, many articles. Most of the articles on misconception, the type of misconception you can find in JCE, Journal of Chemistry Education. Chemistry Education Research and Practice, you can find many teaching approach used to overcome the misconception. Right. So you can the example that I showed just now is the one found in the textbook and reference book. Now, some misconception, mostly the misconception in chemistry, is because of the teacher itself. The teaching itself creates misconception. In chemistry, mostly because you see, in chemistry, we learn concepts which are very abstract. The concepts we cannot visualize by our naked eyes. Kita tak boleh nampak dengan mata kasar. Okay, kita tak boleh tengok. When the teacher say atom, we can only say, okay, atom. In the solid, the atoms are closely arranged. In the liquid, the atoms are separated. There is a distance. The teacher use, normally what we do in the classroom, we draw atoms as a round circle, correct? But how do we know the atoms are in circle? The atoms can be in square also. What? Have you seen atom? We don't know. Just because in the literature, every time people draw in the circle, we also draw in this form of circle. But how do we know that atoms are in circle? So we just follow people's idea. So what happens is teachers use representation. Okay, selalu kita gunakan representation. Kita gunakan modes. We use many kind of modes. Model is one of the modes. We use what you call that, drawing, graph to represent our idea. So as a teacher, you might understand your facts very well. You understand the facts very well, okay? So how the bonding is formed between sodium and chlorine. Sodium release one electron. That electron is accepted by the chlorine. So sodium ion and chlorine anion, they forms the ionic bonding. So you might want to show the students, okay, how sodium ion looks like. So what you do, you show them salt. So you show them salt, but in the salt, they cannot see the sodium ion. They only can see salt. Then you draw the picture, okay, how the sodium ion, chloride will looks like. Okay, this is how it will look like. Correct? So this is representation, because in the salts that you show, they cannot see Na positive, Cl negative. They cannot see that. but then you draw the diagram for them. So you said, okay, this is Na positive, this is Cl negative. Why Na positive is big? Why Cl negative is Na positive is small, Cl negative is big? You explain to them scientifically. But then during your teaching, you said that the bonding is NaCl. Bonding happens between ion Na positive and anion Cl negative. So Na positive happens because one electron is released. Cl negative happens because one electron is accepted. So there is a bonding between Na and Cl, Na positive and Cl. So the student's understanding will be Na positive, Cl negative. There is a bonding. But then when you show two-dimensional view of sodium chloride, of the salt, they will say, hey, how come there is NaCl and they got another NaCl? There are so many NaCl. I thought that the connection or the bonding is only with NaCl. There's one way. But they are also bonding with Na with TCl, Na with TCl, Na with TCl. Do you understand what I'm saying? You know, it's not necessary NaCl, but surrounding one natrium, there are 4 chloride. One natrium, they're surrounded with 4 chloride. So is the bonding NaCl happens with only one Na and one Cl? That means there is no bonding with Na, this Na and this Cl. There is no bonding with this Na and this Cl. You understand what I'm saying? So, and in actual fact, the bonding is Na and Cl. But then when you bring the salt, when you bring the salt molecules NaCl together, they condense and become together. The water is evaporated, they become together. The bonding is between Na and Cl. So these are the misconceptions that might happen when you as a teacher, you use diagram. Okay, diagram to present your idea. Hold on. Okay, diagram representation to present the idea. So if you are not careful, students can have this kind of misconception. Saya harap kamu semua faham. Okay, right. So it is not actually salt is Na and Cl, but there are many NaCl. But how it happens? The NaCl are brought together. When the water is evaporated out, the molecule comes together. But the bonding is between Na and Cl. Okay, right. So this is a common misconception among secondary school students who learns ionization for the first time. Okay, right. So that is from the teacher's teaching. Okay, so we think that as a teacher, when you use representation in chemistry, we can facilitate students' learning. Actually true, because it helps students to see. We want to talk about transition metal, how the color forms in transition metal. How can you go and show the color formation? Because it is so abstract. It happens at sub-microscopic level. You know, so we can only represent. You know, we represent it with the equation. Okay, formation of color is because of this. So microscopic and sub-microscopic works together. You know, but the student should be able to get what you're saying in a way. The intention, your intention as a teacher must be accurately delivered to the students. But in the process of you delivering, there can be some mismatch that can result in misconception. Okay, right. Language. For example, particles. You know, particles means in a common bahasa, particles means dust. habuk. But in the kinetic theory of particles, the meaning of particles is habuk. Huh? You know, right? Particles, the real meaning of particles is habuk, dust. You know, but in the kinetic theory of particles, the name of particle is not habuk. It is a particles, the arrangement of atom, the arrangements of molecules that are called particles. So the language that teacher use, this is very common for the students who are learning chemistry for the first time. 15 years, 16 years, you are teaching kinetic particle theory of matter. There's a lot of confusion, the real meaning of particles. Okay, when you say orange juice, kamu ambil orange juice, you read the label. Okay, what is the content of orange juice? The content of orange juice is sugar, ascorbic acid, citric acid. So people will be thinking the orange juice is not pure because it contains citric acid. Oh, it is very bad. It contains ascorbic acid. So the orange juice is not pure. But in actual fact, what is ascorbic acid? Ascorbic acid is vitamin C. All the citric fruits, they will have citric acid. But the moment, because of the language, people think the orange juice is not pure because it contains ascorbic acid. A simple example, because of language. You know, cultural belief, language, we can talk many things also about language, but this is one or two few examples. Because I believe language ini lebih kepada konteks spesifik. Rather than we talk about English language, it is appropriate if you can have some examples of Indonesian language, because when you teach chemistry or science, you are focusing on Indonesian context. So Indonesian students will have their own language barrier. So if you can focus your study on Indonesian context using Indonesian language, that will be best. That will be good. So these are some examples that I have put in. Same thing, cultural belief and practices. One common theory, science and religion. Darwin's theory of evolution. So Darwin said humans are from ape. It is totally against the Islamic belief. Correct? So we don't believe humans are from apes. Correct? Right. So this is also a kind of misconception. Food based on culture. For us, some food are very nutritious, but for some people, it is a kind of misconception. You know, right? So nowadays, the food-based misconception is actually reducing. It's really reducing. Those days, it used to be really people don't believe some food are really good, but because of misconception, they literally think the food is not good. For example, serai and all that. Serai is a local food. You know, I think the down serai came up maybe 20 years ago. People start to use more and more. Even in Western world, people recognize the goodness of down serai. But 20 years ago, it was not well recognized. There is some misconception about down serai. So these are the food which is really based on the culture and belief. So this is also very much context specific, where Indonesian context might be different from Western world. Normally, the eastern part, Malaysia, Indonesia, all these people, they share similar kind of belief. But when you go to Western world, they have some different belief. Same thing for language. It is very much context based. What I'm trying to say, it is very much context based. Okay. Now, so before going deeper on other misconception in chemistry, I would like to say why misconception need to be eradicated. Why it is so important for the misconception to be eradicated. You see, like for example, from the language, students got the idea orange juice is not pure because it contains ascorbic acid, it contains citric acid, because for their understanding, maybe from their parents or from the other people, they got the idea citric acid is bad for health, ascorbic acid is bad for health. It's because it's all the acid. So we need to eradicate this. We need to remove this from the students' understanding. Right. Now, there is something called mental structure. Okay, mental structure or mental conception. So students have built this prior knowledge. They have come up with this mental conception. So what, as a teacher, what we need to do is we need to remove this, we need to remove or we need to alter this misconception. Okay, we need to alter the mental structure of whatever they have formed. Okay, now you must understand what is the meaning of knowledge construction. Knowledge construction is students construct knowledge. That means in their brain, it's a bit abstract, so you have to follow me. In their brain, in their mental, they already have a mental structure. Okay, now the mental structure is orange juice is not pure because orange juice contains citric acid and ascorbic acid. So because it contains acid, the orange juice is not pure. So that is the mental structure they have in their head, in the brain. So knowledge construction happens from there. When you start teaching about citric acid, okay, citric acid, blah, 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 blah. Orange juice, ascorbic acid is blah, 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 blah. Okay, so the existing mental structure and the new knowledge that you are showing, it must fit to each other. The existing mental structure and the new knowledge that you are sharing with the student must fit to each other. You know, so if the student's idea of acid citric, the student's idea of ascorbic acid, and the information about acid citric or citric acid that you are providing in the classroom is not matching, there is something called a cognitive conflict. Okay, there's something called cognitive conflict will take place. Okay, so students already have a mental structure that orange juice is not pure because orange juice contains acid, which is citric acid and ascorbic acid. And in the classroom today, your lesson is about ascorbic acid. You're teaching the students about ascorbic acid. You know, so this mental structure that saying that ascorbic acid is not good for their health, and the teaching that you're doing, the ascorbic acid is good, is vitamin C, everybody must take, it comes from orange. The one you're teaching in the classroom, it's not fitting with the idea that they have. So when it's not fitting well, students will create cognitive conflict. There's a conflict in their mind. There's a cognitive conflict. So my idea is this: my teacher is telling something else, so that is totally contradicting. That is called cognitive conflict. So you have to remember the phrase cognitive conflict. So cognitive conflict takes place when the student's mental model, the existing mental model, and what teacher teaching in the classroom is not fitting to each other. So when there's no fit, the student will start to think, oh, they will try to do some kind of thinking to fit the teacher's idea to accommodate to the teacher's idea. So knowledge construction happens during the process of student trying to fit their mental model to the teacher's understand, the knowledge that teacher provides. So when this process, it doesn't happen like, okay, happen at once, stop. Berlaku sekejap, berhenti. Berlaku sekejap, berhenti. It doesn't happen like that. It happens continuously. So this process is called knowledge construction. Okay, this process is called knowledge construction. So knowledge construction is possible if the teacher knows that the student having a wrong idea about orange juice. Wrong idea that ascorbic acid is not good for them. If the teacher do not know if whether the students know what is orange juice, what is ascorbic acid or not, they have they really, the students have understood ascorbic acid as vitamin C or not. If the teacher do not know that, she would not be able to design a teaching to address that. Okay, so in order for you to address the misconception, you need to identify the misconception first. So before identifying the misconception, you as a teacher, you need to know the knowledge construction. What is knowledge construction? So knowledge construction is students have mental model. You are teaching in the classroom. So there is a cognitive conflicts happens. Student will rework continuously. They happens in their mind. They will come to a time where they go, the knowledge, what the students have and what the teacher saying will come in line. So that is called knowledge construction. So what I'm trying, whatever I'm saying, it's all inside this slide. So later I will share the slide. You can actually go through the slides, you know. So if the degree of misconception, you know, like they know ascorbic acid is vitamin C, but the students still do not accept because of the word acid there. They are not so sure that ascorbic acid is good or bad. You know, they know orange juice got something to do with vitamin C, but they are not so sure that ascorbic acid because of the word acid there. So if the degree of misconception is lesser, the knowledge construction will happen easily. If the degree of misconception is huge, knowledge construction will take longer. Okay, so constructivism occurs when the prior knowledge is in line. So if it is similar, then you don't have a problem. But if it's not similar, the teacher will have a problem, the student will have a problem. And also the degree. If the degree is lesser, the teacher somehow can overcome. But if the degree is worse, then you will have to construct a teaching which is more appropriate to overcome the misconception. Okay, right. So this is what I have said. So effective teaching or effective learning is only possible when the entire misconception is totally eradicated. You say, okay, my teaching is successful or my students' learning is successful only when the entire misconception is totally eradicated. But most of the time, we can just overcome the misconception, but we cannot totally remove the misconception. Okay, we cannot totally remove the misconception. We can address the misconception to some extent. Okay, so here I talked some aspect. The teacher is important. So if you really want to control the misconception, you want to make sure the student's misconception is addressed, you cannot simply teach. You have to use a correct pedagogy. Okay, you have to design your pedagogy in such a way that you are addressing the misconception. So in order for you to design such a pedagogy, you need to know what are the misconceptions. Okay, so teknik atau strategi pengajaran sangat penting. Okay, kalau tujuan guru adalah untuk mengatasi miskonsepsi tersebut, guru perlu tentukan apa miskonsepsi yang sedia ada. Guru perlu merancang. Okay, guru perlu merancang pedagogi berdasarkan kepada miskonsepsi tersebut. Guru tak boleh ajar macam tu saja, oh, I'm going to teach about atom, I'm going to use representation. You cannot do that way. You have to design your teaching according to misconception. Okay, so in order to that, you need to know what are the misconceptions. Okay, right. So I think I've given you some broad example, but I just want to go through some of the misconceptions. Later, I can share this slide with you. You can go through. There are so many things that I have presented here, then for you to get the idea if I don't have the time. Now, so one good example is misconception about water cycle. This one like primary school students or lower secondary school students are 12, 13 years old. Misconception is water cycles involves freezing and melting of water. But in actual in a water cycle, is there any freezing and melting? Water cycles involves evaporation of liquid, condensation, and precipitation. So we assume that freezing happens. But in water cycles, there's no freezing. But if you go and tanya sekolah rendah, budak pelajar sekolah rendah, they will say water cycle is about freezing. Water only evaporates from ocean and lakes. It doesn't evaporate from any other source. I mean, this one, everybody thinks like that, right? Even from trees, plants, everywhere, water evaporates. Water cycles only includes rain and snow. But water cycle do not include other things. So this is a common misconception that we got it from this person. But in our own study, we did our own study. It's not only this. There are so many misconceptions. For example, when there is no sun, evaporation does not happen. Pelajar rasa kalau tak ada matahari, evaporation tidak berlaku. Evaporation happens anytime, despite having sun or no sun. Water vapor rises from the sea to form clouds. They think the clouds on top is just because evaporation of water from the sea. So there are so many misconceptions, very simple misconceptions. So next week I will show you how actually we can design treatments. Dia berdasarkan drawing based treatment to detect the misconception. So this week I just show you what are the misconceptions. Condensation. These are a very simple topic, condensation. Boiling is a process that involves chemical changes, occurs only at the surface of a liquid. Is it just a chemical changes? It is also physical changes, correct? And it occurs at the surface. Adakah berlaku atas surface saja? But it happens throughout the water, right? The chemical structure of a liquid is changed during the process. Is it true? It's not only chemical structure, the physical points and all that. So these are the misconceptions on condensation according to literature. But our study shows so many other misconceptions. Water vapor cannot be changed into water. So some students think once it becomes vapor, it cannot change back to water. Water vapor cannot exist in air all the times. I think there is water vapor. Forever there is a water vapor in the air, udara. So these are the simple things that actually the students have misconception that we can actually identify. Climate change. This is a wide research. Until now, we are still doing the research, So what is the causes of climate change? Global warming, carbon dioxide, ozone layer. This is a lay person's talking, We think that global warming means climate change. Greenhouse effect, climate change. But actually, greenhouse effect is very good for us. It naturally occurs. Greenhouse effect happen naturally. It traps the air. Without greenhouse effect, the whole world will destroy. We need greenhouse effect. But unfortunately, greenhouse effect is actually worsened by human activities. That is the problem. Okay, so these are some examples that I have actually brought in, so you can read these slides and get some idea. If you want details, you can always ask me or email me or something. I'm willing to share the questionnaire and all that. Okay, global warming. So we always think global warming is something happens at that point because increase in the temperature, but it is not that. Global warming is a slow process. It started from something very small and it has come to this level now. And we always think just because of energy, usage of excessive energy, there is a global warming. It's not true. There are so many other factors actually causes global warming. And we think that, one common misconception is global warming causes skin cancer. It's not true. It causes higher temperature. It's not true as well, because skin cancer is because of the UV light. It's not because of global warming. And some people say climate change cannot be stopped. Some say climate change only can be controlled. So what is the right conception? Right. So again, ozone layer depletion. What is the ozone layer? How the depletion happens? So we are thinking that human action creates the hole, and that is called ozone hole. So the UV light pass through directly reaches human being. But is the ozone hole created by human? So what's the cause of ozone layer depletion? So I have given here some idea, right? Acid rain. And in chemistry, basically because of the abstractness of concept, because of the abstracts, the concepts are very abstract. Like example, I have shown you the sodium chloride bonding and all that. And I've included some things here as well. Okay, now going into the electrochemistry. So what are the misconceptions? Confusion between flow of current in the conductors and the electrodes. So this is a huge field where until today students can find misconception. Flow of current in the conductors and the electrode. How the current flow? Current flow in the through the conductor. They always have a confusion between flow of current and flow of electron. So current and electron flows in the opposite direction. So they are always flow in the opposite direction. So you must know that. Inability to identify anode and cathode, anion and cation, mixing of oxidization in reduction. Until now, I tell you, among you also, you will find a lot of misconception on this electrochemistry. Okay. Chemical bonding. This is also a huge topic. So these are the list of misconception that which are totally related with chemical bonding. Next week, I will show you instrument which actually measures all these misconception. Okay. When I show the instrument, I'll go more detail about how the misconception are measured and why this information are said as misconception. Okay, right. So this is what is in the literature. This what is our study find out. Metals are non-metals from a strong covalent bonding. Is it correct? Metals and non-metals, I thought, forms ionic bonding. Metal is covalently bonded to a non-metal to form a molecule. So these are the kind of misconception that we have identified in our study. Solid copper conducts electricity because it contains ionic bonding. This is very, very common. You can teach students how many times also. End of the day, they will still have misconception. Electricity happens, conduction of electricity is because of flow of electrons, not because whether it is ionic bonding or covalent bonding. Okay, right. Now acid bases. So this is one whole list of misconception on acid bases. Very simple. You know, any substance that contains H positive is an acid, or H negative is a base. Very simple. That means they are telling that acidic solution only contains H positive. It's not necessary. It contains both H positive and OH negative. Only thing is the concentration of H positive is higher. Okay. At pH 0, substance are neither an acid nor a base. It's wrong. pH must be 7. But lay person will be thinking in this way. Acids and bases show opposite properties. Not necessary. You know, acid and bases both conduct electricity because there is a movement of ions. Right. So these are some examples. You know, this is from the literature, and this is also some of our own study. Fruits are basic. This one I would say from the everyday interaction with the family or reading materials. Not all the fruits are basic. Some fruits are acidic. Okay, so soil cannot be acidic because things grow in it. Kehidupan seharian in your family. Sometimes your mother plants something, she will say, oh, the plant is not growing because the soil is so acidic. But it's wrong. It's not necessary. It's acidic. Okay. Right. Chemical equilibrium. This is a very common topic on misconception. You know, we always think that equilibrium has two reactions. One as opposite side, another at the other side. You know, two different reactions. But it's not true. Actually, it's one reaction. It's only thing, it's shifting of the reaction. It happens either this side or it happens on the other side. You know, so this is also a list of misconception. This is from the literature, and this is from my own study. Concentration of reactant and products are equal at equilibrium. Cannot be equal. How can it be equal? Products may be more than the reactant, or reactant may be more than the product. But at the equilibrium, the reaction happens at the same rate. Okay. So these are some of the equilibrium, chemical equilibrium. So I will introduce the diagnostic instrument and also how it is measured. Transition metal. Transition metal is one of my paper published in SERP. So for this paper only, I had a lot of trouble getting this work published because of the word misconception and alternative conception. So when originally I wrote it as a misconception. The reviewer asked me back, why are you saying it's misconception? You cannot prove. But I can prove it as an alternative conception. So I changed everything to become alternative conception. I'll show you what and how next week. You just go through on this, you know. So basically, the four major alternative conception is formation of complex ion. The students have a wrong understanding how complex ions are formed, you know. So they always think all the complex ions, for example, have same ionization energy, but it's not necessary. The ionization energy can be differ. Copper is a transition metal. You know why? Because they think they see, because copper is color. All the transition metals are colored. So because copper is colored, it is known as a transition metal. So these are some kind of alternative conception. So reactivity of transition metal across period from left to right, elements are more electronegative. You know, TMs are good oxidizing agent. Metals only donate electron. Not necessary. Metals also can accept electron. Transition metal easily receive and donate electron. You know, so I'll go through this more detail when I describe the instrument. If I don't have time next week, I will try to at least go through the equilibrium, bonding, acid base, all this I'll try to go through in detail. So you get a very complete understanding of what's happening. Okay, So I think
Yeah.
I'll stop now. So I
Yes.
would like to have some question in order to
Mhm.
know whether you understand what I've said.
Okay.
Thank you.
Thank you very much, Dr. Mages, for the presentation, for your lecture. We still have only 5 minutes to discuss. There's no problem, yeah? We will keep
Sure.
another questions for next week, if you don't mind. Please, students, especially 10 students that I have in problematic in chemistry education and also management of teaching materials, please. If you have any question, silakan langsung di bahasa Indonesia, enggak apa-apa. Dr. Magis bisa memahami bahasa Indonesia ya, Dr. Magis.
I can paham bahasa Melayu.
Ya, oke, silakan teman-teman semuanya. Bisa open cam dulu, kemudian bertanya langsung kepada Dr. Magis, silakan. Tentang miskonsepsi tadi sudah banyak sekali disampaikan. Silakan, Mas Haji atau Mas Umam, Gama, atau yang lain silakan. Karena ini kan proses pembelajaran ya, partisipatif dan project selalu menjadi performance assessment teman-teman semuanya.
Kalau kamu malu nak tanya, boleh tulis mana chat box. You can write in the chat box. I can see the thing.
Silakan. Mana ini yang bertanya? Susah. Oke, begini Dr. Magis, I have a questions regarding your maybe the third slide or fourth slide ketiga atau slide keempat tadi ada chemical free product kan gitu ya. Nah, itu dianggap miskonsepsi bagi yang memang tahu gitu. Tetapi menjadi bukan miskonsep kalau orang-orang tidak paham bahwa chemicals, ini mereka tidak tahu, bukan berarti dia miskonsep, memang tidak tahu bahwa memang ya harusnya memang tidak ada chemicals, maksudnya seperti itu, karena because this negative perception of chemistry. So this is misconception for the chemists, for the people that know about chemicals, but how about the society or the people that don't know what is chemistry is?
Right. So what I'm trying to say is, I think as a chemist, we are aware. I mean, everybody, as a chemist, we are aware that it is impossible. Tak mungkin kita boleh hasilkan satu produk tanpa bahan kimia. Yang perlu kita tahu ni, bahan kimia ni berbahaya ataupun bahan kimia tidak berbahaya. Bukan semua bahan kimia berbahaya. Ada bahan kimia yang berguna. Banyak bahan kimia yang sangat berguna. But literally, the society outside there, dia suka gunakan label chemical free. But as a chemist, you should understand, how can you have a product chemical free? Mana boleh kita hasilkan produk yang tak ada chemical? Satu contoh lah, daun pandan. Bolehkah kita kata daun pandan tu tak ada chemical? The chemical structure of the daun pandan is the one gives us the flavor. But people will think, oh, daun pandan is chemical free. So that is what I'm saying, a very, very classic example of misconception. The lay people. But I think as a chemist, I don't think we will have that misconception. But students, they will have that misconception. The students who are learning chemistry for the first time, lay people outside there, yes, they will have this kind of misconception. So that's why. So taking that example, ambil example tu, contoh tu kita letakkan dalam konteks kimia ataupun sains. Ada dua perkara you have to highlight, you have to teliti di sini. Dua kemungkinan pelajar tidak tahu langsung. That means they don't know. They don't know. That means you have to teach. Sebagai guru, kamu kena mengajar dia, baru dia akan tahu. Fenomena pertama. So yang ini bukan miskonsepsi. Yang ini dia tak tahu, dia tak faham, dia tak mengenali. So guru perlu ajar dulu, baru dia akan faham. So yang ini bukan miskonsepsi. Yang kedua, cikgu ajar tetapi dia salah faham. dia interpret differently. Like for example yang sodium chloride yang saya tunjuk tadi. Sodium chloride is an ionic bonding. Both the sodium and chloride join become a salt, right? Tapi inside the salt, there's not only one sodium and one chloride. There are so many sodium chloride. But the bonding is between sodium and chloride. You know, so bagaimana, how the other sodium chloride happens? Is it because there's also bonding with one sodium with another chloride, or sodium forms 4 bonding with the 4 chlorides surrounding there? You know that, you know, but actually in actual fact, the bonding is what? Sodium chloride, sodium chloride, sodium chloride, sodium chloride. But dia bila water is already absorbed, they come together. Correct? There is not more bonding sodium with chloride, 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 sodium with chloride, chloride. There's not such a thing. Do you understand what I'm saying? It's just that sodium chloride, sodium chloride, sodium chloride, sodium chloride. There are many, many molecules of sodium chloride. You bring them together, it forms sodium chloride salt. You know, but when you do not teach student properly, student will understand in a way that sodium chloride, this sodium will form a bonding with that chloride, this sodium with this chloride, this sodium with this chloride. You see, that is misconception. It is not wrong. It is not dia tak tahu, dia salah faham. They misunderstood it in a wrong way. That's misconception. So in your writing, especially when you send for your article for review in a very good journal, they will ask you how you know this is misconception, and bukannya dia student tak tahu.
Yeah.
So there is a way to measure it. So normally we will use 3 tier. Sekarang ada soalan 4 tier pun ada.
Yeah.
So that's what I will talk about it next week. How to measure. So this week, I mean, I think I'm not sure. When I started the research on misconception, I was thinking everything is same. And I tell you, I also review many papers in science and chemistry. Many people will write in such a way. Misconception dengan tidak tahu is just literally sama. It's not wrong.
Yeah.
So you cannot say students buat salah sebab dia kurang salah faham. Dia mungkin tak faham ataupun dia tak tahu. That's what ini lah. So I have some question here.
Yeah.
Yeah.
Ada pertanyaan dari Aji, one of our students, Dr. Mages, mengenai miskonsepsi. Jadi ini biasanya karena berbeda guru. Jadi yang guru satu seperti ini, guru satu bilang A, guru B bilang B, kan gitu ya. Bagaimana kita bisa sinkronkan materi, itu satu. Terus yang kedua, misalnya pada konsep ion, ya guru meminta siswa membaca sendiri. Jadi kadang memang apalagi pandemi seperti ini, Dr. Mages, banyak yang tidak ada penjelasan guru membaca, kemudian masih banyak tentang konsep salah ion, konsep mengenai ion itu sendiri.
Oke, ya, saya coba jawab yang pertama tu ya. Terkadang memiliki guru yang benar, ini terkadang misconcepsi, bagaimana kita
sinkronkan, diagnose.
Okay. So, that's why ini tadi saya tunjuk slide kan, saya tunjuk miskonsepsi dalam water cycle kan. So actually that is a very good example. That misconception is from the literature. Okay, itu adalah miskonsepsi yang saya dapat daripada literature. Lepas tu bila saya buat study dengan my own student, looks like bukan itu saja. Mereka ada lagi banyak lagi miskonsepsi. So I cannot say what is in the literature exactly happen in my own context. Rupanya ada benda-benda baru lagi yang boleh berlaku. So in this case ada dua cikgu. Cikgu pertama, cikgu kedua. Cikgu pertama mengajar kelas yang lain, cikgu kedua mengajar kelas yang lain. So bila dibuat pengajaran, didapati kelas pertama miskonsepsinya lain, kelas kedua miskonsepsi dia lain. So kalau kita gunakan instrumen yang standard daripada literature, kita tidak akan mengenal pasti, kita tidak ada peluang untuk mengenal pasti miskonsepsi yang mungkin tidak ada dalam instrumen yang standard. So apa yang kita boleh buat, sebab tu mixed method study is very important in misconception. Kita bukan saja menggunakan instrumen, kita pun buat some qualitative research. Qualitative research, it can be interview, can be observation. From there, kita dapatkan banyak lagi miskonsepsi yang tidak ada dalam instrumen standard. Saya rasa benda ni penting sebab apa? Bila kita mengajar satu kelas, kita perlu merancang kita punya pengajaran berdasarkan miskonsepsi pelajar tersebut. Kita tidak boleh mengajar ikut miskonsepsi yang standard sedia ada. Kita perlu dapatkan apa yang spesifik untuk kumpulan pelajar ini. Lepas tu kita rancang. So, kita tak boleh guna instrumen yang standard tu sahaja. That's why I said mixed method research is important. Mixed method research will allow you to identify what are the misconceptions specific untuk pelajar kamu. I hope I understand the question. I answered the question.
Ya. Oke. Masih ada satu pertanyaan, kita jawab sekaligus, Dr. Mages?
Ya.
Ibu Paramita Purbosari bertanya, banyak miskonsepsi terjadi pada pembelajaran IPA, science learning di elementary school. Bagaimana memahamkan siswa dengan ilmu IPA yang belum begitu tinggi atau belum terlalu luas. So this is for primary students, primary education students, Dr. Mages, because they still have low conceptual understanding about science. This is the questions.
Okay.
And then, please.
Okay, I will try to answer this, and also another one. Konsep ion sendiri siswa membaca. Okay, yang membaca sendiri ni memang in science is very difficult to students baca sendiri unless they are at a higher level. Even that time also you will try to deliver create misconception. You know, memang baca sendiri in chemistry is quite well. You need somebody's assistant in order to eliminate misconception. You cannot let the students learn, especially yang baru mula-mula nak belajar kimia ni. You know. Now yang kedua ni, that's why I said the most common theory itu adalah kita sebut sebagai conceptual change model. Kamu pun boleh baca nanti. Conceptual change model by Posner, 1982. Posner kata, all our teaching should, kalau kita nak address misconception, all our teaching we must design according to the 4 steps. It doesn't matter if your teaching is at the primary ataupun if your teaching is at the higher level, secondary or tertiary. As long as you can design the teaching according to 4 steps, you should be able to eradicate misconception. So, then when I talk about the theory, I will go very detailed how you can design the teaching so that you can follow the 4 steps. At the same time, you can reduce the misconception.
Okay. Yes. Good. Dr. Mages, we should keep another questions for next week because now is already 10 past 1. Is it okay? Yeah. I will keep it for next week. Because some students have not got afternoon free. Yeah.
Right.
Okay. Good. Bapak, Ibu, adik-adik semua mahasiswa, I think this is the first meeting with Dr. Mages. We have already learned many things. Misconceptions start from the definition, the concept, until example. The misconception we can find in the literature. Yeah, start from science and chemistry itself. And next week we will continue to learn about the instrument to diagnose the misconception, right? That already done with by Dr. Mages and team, and also some literature.
Yeah.
And thank you very much for your participation today. Hopefully you still can enjoy your holiday, because we are in 2 hours. This is also one of the things that we can enjoy our holiday with Dr. Mages. Okay, thank you very much, Dr. Mages, for
Thank you.
this is for the first meeting. That's nice presentation, and everybody, I think, have a very good understanding of your presentation. Thank you very much, Dr. Mages.
Thank
See
you,
you
Dr.
next
Nurma.
week.
Thank you, no problem. So I will try to go for go detail 3 or 4 instruments. I don't know can go more than that or not. I try my best to go at least 3 or 4 instruments.
All right.
But the instruments would be in chemistry.
Yes.
I see lah how it goes. Okay.
Good.
So,
Terima kasih juga Bapak Ibu yang masih bergabung di sini, Dr. Mages. We have Bu Lina, Pak Waton, also lecturer from Chemistry Education Department.
Right. Thank you so much to be with me. Thank you so much.
Okay, thank you very much, Dr. Mages and participant. See you next week. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, bye-bye.
Bye-bye. Thank you very much.
Bye.
Thank you very much.
Thank you. Bye-bye. Bye.